I'm going to show you 5 different ways of figuring out the distance traveled given a velocity over time graph. And the last one requires calculus, so you're probably not going to be able to use it until 1 or 2 years from now.
This is a VYT, okay. This is initial velocity is 10, final velocity is, let's say, negative 40, and the time is 3. I want you to find the displacement is 6 different ways. The first way is BH plus half BH, right? And that's going to give us a displacement. B is 3 and H is negative 10 plus half. B is 3 and H is negative 30. So the displacement is negative 30 minus 45, so displacement is negative 75. Now Shubhana is going to show a different way.
Displacement is equal to initial velocity plus half times the acceleration times time squared of initial velocity times time. Sorry, I forgot to state that. So the initial velocity, as we can see in this graph, is negative 10. The time taken over this interval is 3 seconds, plus half. Well, to figure out the acceleration, we're going to need to figure out the slope of this line. What's that going to be? Well, it's the difference in y, which is negative 40 minus negative 10, divided by the difference in x, which is 3 minus 0, which is minus 30 over 3, or negative 10 meters per second squared. So we know that's our acceleration. And then what's t? 3, so we just square that. So then we get minus 30 plus what's half of negative 10, that's negative 5 times 3 squared. And of course we know that 3 squared is 9, so we get minus 30 minus 45, which is equal to minus 75 meters.
This is the second way. I'm going to do it third way. I'm going to say displacement is average velocity times t, delta t. So average velocity is Vf plus Vi over 2 times delta t. Okay, so what is Vf? Vf is negative 40. What is Vi? Vi is negative 10 times 2. What is delta t? Delta t is 3. So what do we got? Negative 40, negative 10, negative 50 divided by 2, negative 25 times 3, negative 75 meter. Okay, so Shubhana gonna do another way, fourth way.
Use Vf squared equals Vi squared plus 2AD. So what's Vf first of all? Well, that's clearly negative 40. So we plug that right into here. And what's Vi? Well, that's negative 10. So we plug that into there. We calculated the acceleration last time as negative 10, misremembered, times the distance, which we want to solve for. So what does this become? Well, negative 40 squared is, of course, 1600. Negative 10 squared is 100. And we get minus 20 as the coefficient of d. So that means 1500 equals minus 20d, or canceling out a factor of 10, 150 equals minus 2d, which means d is negative 75 meters. Now we can also show this via calculus. So first we have to figure out the equation of this right here. So we already know that the y-intercept b is negative 10. So we know since this is linear, it's going to take the form y, or rather v of t is equal to mt plus b. We already know that y-intercept is negative 10. Now we just got to plug in one of the points to solve for n. So we can, for example, plug in 3 comma negative 40. So if we plug in negative 40 for v and 3 for t, we get this. So that means negative 40 plus 10 is equal to 3m. So minus 30 is 3m, and m is equal to minus 10, which means our velocity over time equation is equal to negative 10t minus 10. Now, since distance is the integral of velocity, that means that to figure out the total distance, we need to take the definite integral from t equals 0 to t equals 3 of minus 10t minus 10 dt. So what's that going to be equal to? Well, we factor out the factor of negative 10 to get the integral of t plus 1. And of course, we know that's just the indefinite integral is t squared over 2 plus t. But, of course, we're taking it in a range from 0 to 3. But the thing is, when we plug in 0 here, this becomes 0. So we're effectively just plugging in 3 to get 3 squared, which is 9 over 2 plus 3. So what does that get us? Well, that gets us negative 10 times what's 9 over 2 plus 3? Well, that's equal to 15 over 2. So we get minus 10 times 15 over 2, which is minus 5 times 15, or negative 75 meters.